Welcome to Time Before Space, the channel where we embark on a journey to explore the wonders of this universe. You might have noticed that in just the last few centuries, we have undergone a remarkable transformation in the way we perceive our universe. And physics has played a pivotal role in revolutionizing this way of our understanding of our reality. Take, for instance, the concept of time. Before Einstein, everyone thought that time was an absolute unchanging force, which did not care about your speed or location. But Einstein's groundbreaking work of special relativity altered this very notion of the absoluteness of time. Time still flowed, but relativity enabled us to stretch or elongate the intervals of time. As a result, we discovered that we could walk or even stretch time, depending on our speeds or location. The famous statement that comes out of relativity is that clocks tick differently for observers with different speeds. Suddenly, the ideas which were once relegated to the realm of science fiction were no longer that. They became reality. Today, our focus lies on three such interesting principles that changed the way we perceive our reality. These concepts represent the most drastic revisions of our understanding of the universe. So, without further ado, let's dive in. The principle of equivalence in the theory of general relativity shows that acceleration and gravity are closely linked. It says that all objects, regardless of their mass, fall in the same way under the influence of gravity.
And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon, and I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
Locally, it's impossible to distinguish between acceleration and gravity. Let me present you two scenarios and then ask you if your experiences in these two different scenarios would be different. In scenario 1, imagine that you were floating far away in deep space, away from all stars and planets. You wouldn't feel any force on you as there's no gravity to act on you, as there are no masses around you. Now imagine another scenario where you were skydiving on Earth, removing the air resistance. So now that we've taken the air resistance out of the picture, if you close your eyes during your fall and do not look at the Earth below, you would feel floating. You wouldn't be able to tell if you were floating in deep space or if you would be floating while skydiving here on Earth. This is because the experience of free fall feels the same in both scenarios. This principle was so important to Albert Einstein that he considered the idea of floating while freely falling towards Earth as the happiest thought of his life. Einstein changed the way we look at freely falling objects. This deep principle led to an understanding that it is not the freely falling objects that are accelerating. Rather, it is us who stand still here on Earth who are accelerating. The simple yet profound principle laid the foundations of space-time curvature, which explained the physics behind many objects, including black holes. It profoundly changed the way we perceive gravitational force and the way we view our universe. A fundamental concept in quantum mechanics is the Heisenberg's uncertainty principle. This principle dictates that certain pairs of properties of particles can never be precisely measured simultaneously. The more accurately you measure one of the properties, the less accurate your knowledge of the other one becomes. This uncertainty principle has significantly changed our perception of nature, especially at the subatomic level. Before its discovery, classical physics would have told you that if you have an object and you know its position and velocity at a given time, then using the laws of physics, you could predict its future behavior with absolute certainty. But not anymore. This uncertainty principle shattered the deterministic view that we had and introduced a fundamental indeterminacy in quantum systems. To help you understand this, let's take a cute analogy. Imagine capturing the playful moments of a puppy playing on a field with your camera. You click various photos of the puppy, and some of them are blurry. You choose two of these photos, one which is blurry and one in which the image of the puppy is sharp. In one photo which is blurry, you can quite accurately guess the puppy's speed using the direction it's moving and the details of your camera's shutter speed and other things. But if I ask you to pinpoint to its location in that photo, the blurry image, you would have no clue. In the other photo where the image is sharp, you can precisely pinpoint at the location of the puppy. But now you have no clue of the direction of its moving and hence cannot tell me its speed. This playful trade-off reflects the essence of the uncertainty principle, where the more you know about the position of a particle, the less you know about its momentum, and vice versa. In summary, Heisenberg's uncertainty principle has profoundly changed the way we perceive our reality, introducing indeterminacy and uncertainty as inherent aspects of the quantum world. Another fundamental concept that has reshaped our understanding at the quantum level or the subatomic level is the idea of superposition. According to the superposition principle, a quantum system can exist in multiple states simultaneously before it is observed. These multiple states are represented as what we call superposition of the possible outcomes of the observation that you make. When an observation is made, the system collapses in one of these possible outcomes, which seems to be at random. Imagine yourself in the quantum world. Let's try to understand how this principle would lead you to make your observations. Picture a flashing light right in front of you that can turn into two colors. When you close your eyes and stop observing, the light mysteriously exists in both colors simultaneously. However, the moment you open your eyes to make an observation, the light quickly reveals itself in one of the two colors. It's as though the light signal mysteriously knows precisely when you're watching and when you're not. This mind-blowing implication of the superposition principle leaves us in awe of the unconventional nature of the quantum realm. Furthermore, this superposition principle forms the very basis of quantum computing, where the quantum bits, or qubits for short, can represent 0 or 1 simultaneously. This improves the capabilities of computers, making them quantum and exponentiating their processing capacities. Together, these principles have transformed the perception of our nature, unveiling a universe that is far more inspiring than we could have imagined. Thank you for joining us today on this captivating journey. I hope you enjoyed this video on principles that change the way we perceive our reality. Don't forget to like, share, and subscribe, and hit the notification bell button for more similar content. Also, in your comments, do let me know which other principles have inspired or excited you. Until next time, signing off, your host, Madhur. Keep exploring and stay curious.